Hello, geometry students. We're going to be looking at stuff today that has to do with solids and 3D shapes. And really, this whole unit we're going to start today is going to be all about three-dimensional shapes. So we've got to stretch our thinking a little bit. We've been on 2D for pretty much the whole year. So now we're going to get into three dimensions. And so the very first thing I want to do is talk about what a solid is and some different types of solids, and in particular, one specific type called a polyhedron. This is kind of like the 3D version of the word polygon. To be a polygon, it had to have straight sides, be a closed figure, all that stuff. So to be a polyhedron, kind of that same stuff happens, and we're actually going to use that word polygon in the definition. To be a polyhedron, it has to be a solid, and a solid just means it's a three-dimensional shape bounded by, so it's closed off by polygons. So it's a bunch of polygons stuck together to close in this three-dimensional shape. So here's an example of a polyhedron. Do you notice it's all polygons stuck together to make this thing? We've got basically like a rectangle, maybe a square on the bottom, or a rectangle, maybe a square on the top, a smaller one. And then it's really like trapezoidy looking things coming up to close this thing off. But they're all polygons put together to close this off. That's what makes this a polyhedron. All right, and the parts of a polyhedron. We always have faces, vertices, and edges. Faces are the polygons. So this entire thing is a face. This square up here is a face. The edges are the segments that are put together to make the polyhedron. And then the vertices, or vertex is the singular, are the points where the edges come together. And so I want to look at how many of each of these things there are on this particular polyhedron. So you notice for faces, we've got this rectangle on the bottom, so there's a face. We've got a rectangle on the top, there's a face. We've got a trapezoid here on the right-hand side, trapezoid on the left-hand side, we've got a trapezoid on the back, and a trapezoid on the front. So faces, like polygons stuck together, we've got 6 faces. Vertices, so the points where the edges meet, we've got 1, 2, 3, 4 on the bottom, and another 1, 2, 3, 4 on the top. So total, we've got 8 vertices in this. And then edges, we've got 1, 2, 3, 4. And I tell you what, let's do this, because I think it'll make it easier to keep track of them, because this is something that can get confusing trying to count these. I'm just going to put a little tick mark on each one as I count it. So I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 edges. All right, so I've got 12 edges here total. All right, so let's see if we can come up with a formula that relates faces, vertices, and edges, because there is a formula for this that's going to work. And I've started it. It's called Euler's formula, or some people pronounce this Euler. It's the guy's name who came up with it. So faces plus vertices, that's what F and V stand for, equals, it's not just edges. Because faces plus vertices here, you notice here is 6 plus 8, that's 14. The edges is 12. Do you notice, though, faces plus vertices just came out to 2 more than the amount of edges here? And that will happen every time. It's always faces plus vertices comes out to 2 more than the number of edges. And so faces plus vertices will always equal edges plus 2. And some people will say this faces plus vertices minus 2 equals edges. If you like that, that's fine. It's just basically doing algebra and moving the 2 to the other side. Whichever way you want to remember it, it's good. But what this allows you to do is if you have any 2 of these 3 things, you can always figure out the third one using that formula. Just basically treat it like an equation and leave whichever one you're trying to find as the unknown and fill in the 2 that you know. So if you know F and E, faces and edges, you can find the number of, or faces and edges, you can find the number of vertices. All right, so let's see if we can just look at a couple examples here. And the question on this is this a polyhedron? So to be a polyhedron, we saw the definition up there. It has to be all polygons stuck together to make this thing. So this first one here, is this a polyhedron? Well, we've got basically a square on the bottom here, and then we've got 4 triangles coming up from there. Square is a polygon, the triangles are all polygons, and so everything here is a polygon, so that's a yes. And I want to introduce you to some names of a couple of these shapes. This shape is called a pyramid. Probably just you've heard of like the pyramids in Egypt. This is that same shape. We call it a pyramid. That's the name of it. Um, and then let's go to part B. All right, so for the bottom of this, we've got a circle. Or the base of this, I should say, we've got a circle. This is supposed to be a solid bounded by polygons to be a polyhedron. A circle's not a polygon, which means this, even though it is a 3D shape, not every 3D shape is a polyhedron. It has to be bounded by polygons to be a polyhedron. So this is not a polyhedron because a circle is not a polygon. So that's a no. The name of that shape, we call that thing a cone. So a cone is not a polyhedron. This shape right here, and so I know if you just look at it from the side, it kind of looks like a circle. That's why this is in here to show it has some depth as well. So it's like a 3D circle. We call this thing a sphere. Now, this one, there's actually no polygons anywhere on this thing. There's not even any 2D shapes. It's just like this continually curving surface. And so there's no faces because there's no flat surfaces. So that's a no. That thing is not a polyhedron. And then that thing is called a sphere, by the way, is the name of that thing. And then this last one here, we've got basically a bunch of squares stuck together. And so putting all these squares together, we actually have 6 squares, but they're all polygons. That's the big thing. And since they're all polygons, this is yes, that's a polyhedron. And the name of this one in particular is a cube. If they're all squares that are put together, the same size squares put together. If these were different, so let's say the top and bottom of this are actually rectangles, not squares, we would call this thing a rectangular prism in that case. Right, so that's how we can tell if something is a polyhedron or not based on its, if it has faces, vertices, edges, or in other words, if it's bounded by polygons.